Hey there, everyone. Ryan Schul here. So the narrative today, I think, is very, very, very interesting. I'm going to show you how to create profiles and how LinkedIn creates these lists that are called people you may know. And it consists of basically, I think it's called a list, maybe a profile list or something like that. But it's going to show you all your connections and your potential connections. I mean, the potential connections based on things like where you went to school. Do you people work at the same company? Do you have friends in the same network, right? If you have these overlapping patterns, there's a few algorithms that you can use to say, okay, you know this guy and you know this girl knows this person. All of you went to the same school. We're going to recommend this person to you because you might know them as well, right? And maybe you're not connected. If you're already connected, then you're not going to connect, right? You're not going to reconnect. But maybe it could be people that work at your company. If you work in an accounting department at a specific company, and you know this person and this person knows another person, you might know that person as well. So that's recommended as somebody that you should add to your, it's called people you may know list. So that's what they call it, I believe. So I'm going to show you how it works here. So I put together some scripts. I tested it over the course of a couple of days. Everything is in Jupyter Notebook, okay? Of course, right? This is how I do everything. And I will share the script with you guys when I post the video later today. So basically, I want to come up with some hypothetical companies, schools, cities. So I don't work at LinkedIn, okay? Full disclosure, I never worked there. I don't even know anybody that works there. So I can't say definitively this is how they do it, but this is the concept that will showcase probably how they do that. So theirs might be slightly more complicated. That's a big website, right? With how many members they have? 200 million or something like that. It's pretty vast. It's pretty diverse. So I'm not saying this is the exact replica of what LinkedIn is doing, but it's probably substantially similar. Theirs is probably a little bit more complex, maybe even simpler than this. I'm not sure. They probably have a bunch of people working on, the brand, the web page, the database, the servers. I did this by myself, so I can't say for sure if theirs is easier or more streamlined, right? Maybe they have a lot of people working on it and they say, oh, we can cut this out, we can cut this out, we can make this more efficient. That could be the case. Their concept might be slightly more complicated because it's substantially bigger than this, right? But I think this should show essentially how the math and the computer science behind it works. So we have a few companies here. Again, I'm just making this up, a couple schools and a couple cities. And once again, this should make sense. The concept is if you work at this company and another person works there, you might know the person. If you went to this school and another person went to this school and you guys are not connected, maybe you know this person and you want to connect. Same thing with cities. If you came from a certain city or a certain neighborhood within a city, if you call that home, and another person is in the same neighborhood and you're the same relative age and these profiles kind of match and they're kind of similar, they're going to recommend these people to you so you can connect with them and broaden your connection base or network, right? So I'm going to use a graphing tool. This is Network Graph. It does a fantastic job of looking for nonlinear relationships between different groups. And I've used this in several of my videos. If you do graphing, graph searching or whatever, you can probably find a bunch of them. Let me see. This is my channel over here. If I go over here to the dashboard, GraphX, GRAPH. Yeah, so there's a few. How to use a graph-based model for detecting fraud, how to create a graph-based model to help understand fraudulent or detect fraudulent banking transactions. Okay, these two actually sound kind of similar and they came out around the same time, but I'm sure the concepts are different. I don't duplicate my work and I don't replicate things because there's no point in that. So they're going to be similar in some cases, the network connections part, but the analysis is going to be quite a bit different, right? So I have network analysis versus graph analysis of stocks and then graph analysis using Python. So there's a bunch of problems you can solve using graph analysis techniques. So I'm going to go ahead and hit enter to run this. Again, I have companies, schools, and cities, and I'm going to go ahead and pick these and create this network graph because I don't have this because obviously I don't work at LinkedIn, right? I don't have access to their data. I don't have access to their servers and things like this, and I don't even want that. I don't want that, right? But I'm going to create a hypothetical dynamic data set here to show you how everything works. So here's the names of the people, right? These are the people that might want to connect, again, based on the relationships that exist. schools, neighborhoods, and where you work. These are the three things. And it's obviously like there could be other features that you want to bake into the analysis, and these graphing tools are great for that. The tool might slow down a little bit if you're dumping in tons and tons of information, but they tend to be pretty straightforward and pretty robust. So I can see if you're trying to analyze billions of records, it's probably not going to work too well. It probably won't work at all, to be honest. But if you're looking at tens of thousands or hundreds of thousands or even millions, you should be all set. In this case, it's going to be, I think, a few hundred records. So we have 20 nodes and 706 edges. So we're under 1,000. So this should be quite performant. Okay. So I'm going to use PyViz over here. It's already creating the chart. Let me just let this thing run, because if I switch back to this page, I think it stops. I think the focus has to be on this page to run it. Okay, so it's doing all the graphing and the analysis right now. Okay, and this is what it comes up with. So I like these PyViz graphs. They're very dynamic and interactive and very visual. You can drag the nodes around and you can see all of the relationships follow these. So let me jump back here in just a couple minutes and show you under the hood what's really going on here. So we have Network X. That's how we're creating all this network analysis and looking at the relationships. Without that, I don't even think this problem can be solved. Maybe there's some kind of ML algorithm out there that you can substitute for this Network X, but I'm not aware of anything like that. It's really unique. And again, it looks for all these different possible nonlinear relationships and ties everything together, kind of like a big spider web. You just saw the chart a moment ago. I'll flip back there in a minute. So we're going to use these Network X graphic libraries, and again, focus on the companies, the schools, the cities. Here's the people's names. And we're going to look at relationships and assign certain weightings. So you can change these, right? And the outcome is going to be slightly different. You can say we want weightings, that are greater than 80%. So it's highly likely that you will know this person through some type of friend connection, school connection, neighborhood living, general vicinity. You might know the person, and we can make these recommendations. You can relax these weights and these constraints and say, maybe there's more like a 50% chance or just 30% chance. We'll serve up a whole bunch of people, and you can pick and choose the ones that you want to connect with. Now, I've seen both of these. I've seen LinkedIn make recommendations for people I absolutely know and I connected with them. But I'll tell you, I get a lot of duds, and a lot of these things most of the time will pop up, and it's like, I don't know that person, I don't know that person, I don't know that one, I don't know that one, I don't know that one, that one, that one. And maybe based on your user profile and your your professional career track, maybe you still want to connect with that person. So that might be a good idea, even if you have no idea who this person was, your paths have never crossed. Maybe your profiles are similar enough, just 20 or 30% at the company where you work, and you can still say, yes, I want to connect with this person. I think that's a good idea. So you have some flexibility here. You have some controls. You can amp it up and say, these people are most likely to be in your network or should be in your network, or here's a whole bunch of people that you might want to interact with and create connections for, and add to the people you may know list. So you could go a couple different ways with that. So I like this PyViz. This is what creates the dynamic interactive graph that we just saw. And we'll go back there in just a minute. So for all of these networks, we have to loop through every possible iteration. So that's why we're creating this loop here. For K and company, school, and city, we're looking at a tuple here. This is a tuple defined by the curly braces right here. All right. So for K in this list, we're going to look at all possible combinations and assign some mathematical representation over here. Okay, we're doing kind of the same thing for U and enumerate users. So we're going through all the users. For V and users I to end. So we're going in the first list of the users, or the first column of the users. Then we go to all of the columns in this user group to pick up every possible combination. And again, look at the weights or the strengths of these different relationships. That's the point of this whole exercise here. So we're looping through all the companies, schools, and cities. If there's nothing there, if the file name is nothing, we're not going to do anything. Otherwise, if something exists, HTML rendering, we're going to go ahead and render the image in the notebook. You saw that just a second ago. We'll go back there soon. And we're going to add these features to the PyViz graph. Okay, so again, PyViz, you can Google this and look it up. It's pretty cool. It's a network graphing tool that's dynamic and interactive. You can zoom in, zoom out. You can put your mouse over the different connections and the nodes, and it's going to show you the details of each. So we're coloring by company. The size or the diameter of the circle is going to be by the degree of the relationship, and the layout is going to be spring. So spring is kind of bouncy. It moves back and forth. We can have Kamada. Never even used this one before. Let me see what this does. Or we can have none. So Control Enter to run. This might be more of a straight linear type of relationship. I've never even tried this one before. Okay. Kind of looks springy to me. I'm not sure what the other one was. Maybe the movement is a little bit different. This one seems to be a little bit faster. I don't know. I'd have to look in the documentation to see what Kamada is. I'm not sure. But I've used Spring many times in the past, and it's worked perfectly fine. So you have a couple of other parameters. Some of these are just optional. Some are mandatory. Usually the first couple parameters are optional. I mean, are mandatory, and at the end, these are more optional, right? So we're looking at, again, the layout is going to be spring, otherwise Kamada. These features or these options come from over here, right? So you can pick a couple different, not parameters, but a couple different sort of like controls for how the graph is rendered. So if layout is spring, we're going to use the interactions 300. I guess the only difference I really saw is this one moves kind of slower. It's kind of slug. Wait, this is the... Wait a second here. This is the Kamada, right? Yeah, because I reran that and put that to the right. It always goes to the tab on the right. So I don't see a whole lot of difference here. I guess just the speed with which the network graph is rendered and refreshed. Maybe that's the only difference there. Again, I'd have to look at the documentation. I'm not sure about that. So based on the company, we're going to create a color based on the degree of the size of the relationship, but we're going to create either a larger or smaller diameter circle. And again, the layout is going to be spring, so you can see all the relationships between all of the people in your network and potential people that you might want to add to your who you may know list. That's what they call it, who you may know. Okay, so we're going to create a title down here and a little HTML just to add in some controls at the bottom of the screen. So if you go down here, you can see you can change some of these controls, and it's going to have an impact on how the image is rendered. I mean, it can be kind of nice. It can be kind of fun and interactive to play around with the stuff. It's not like super, I don't think you want that. It's not super important to, even that is kind of disturbing a little bit. Let me put it back to here and zoom out just a bit. Okay, so I think that's okay. And then you have a couple more controls over here. So you can play around with this stuff and see how it works. It's kind of cool. It's kind of neat how everything is utilized there. So actually I did see one thing. Now I kind of lost the details of my view. So let me go down here and change one thing. If I do this a little bit and this a little bit, I think the image is just rendered just a little bit better. That's just my personal preference. Okay, so if we go back here just to finish off the narrative here, we have to create the nodes and then the edges as well. So the edges come from here. The nodes were done right over here, I believe. Or the graph was done there. Okay, oh yeah, here's the nodes. So we have the overall graph, right? Then we generate all the nodes. We can see the title, company, school. So these are all the smaller circles that you see. And then the edges are the lines between the graphs. And then we'll take everything, once it's set up in this user-defined function, call the function, and then dump everything into PyViz and then render the image, okay? So everything goes into Legend. Legend flows down here. Okay, and when we run it, I'm not going to redo it because you already saw what the output was. It's right here. If I zoom in a little bit, you can see the color of the school is going to be the same. So this person went to Stanford. This person went to, wait, the color is by the company. Okay, yeah, by the company. So you can change that, right? If you want the color to be by the school, just change it back in the variable selection. If you want it to be by company, that's fine. So the company right here is Vandelay. This should be Vandelay. That looks like the same company, same color. So this is Vandelay, and you can see the school is UT Austin. And what else over here? Different company. So this is Globex. This should be Globex because the color is the same. And this should be Globex over here because the company is the same and the school is different, right? But I think this is pretty cool. It shows you all the relationships, right? The strength of the relationship is represented by the size, right? And all of these nodes here are connected with these edges. The edge is a line in between, right? You can zoom in and zoom out and see all the details. So I think that's pretty cool. And of course, you can see the details of the person's name, the title, the company where they work, and then the school where they got educated, and then the city as well, right? And so all of those come from over here, or I'm sorry, from over here, name, title, company, school, and city. They come from over here, right? That's the HTML rendering of the layout down there. So that's pretty cool, I think. If we scroll down here a little bit more, we have some attributes here that we can print out. So that was the visual rendering of all the relationships. But I think it's also important to print this so you can just see it statically on the screen. Like, I think this is very compelling, definitely pops for me, kind of jumps off the screen, and you can see all these relationships, all the nodes, all the edges, move it around, and you can see the strength of the relationship between all of these different people right here. So I think that's pretty cool. But if you just take that and stick that in front of a stakeholder that you're working with, the person might be a little bit confused. I mean, it is edifying and it is, it's very interesting. But to get the real details behind this, I think it's a good idea just to print this out. Okay, so we have the person's name, company where they work, the school they attended, the city where they live, and the title of this person. So all of that is reflected over here, right? But again, even though the graph looks very compelling and kind of draws you in, I think it's definitely captivating here. But I think you would also need the details, and this is where the details come from, right? And that's how we get everything from that graph too, because the graph just doesn't magically happen, right? It has to be based on some type of data, and I think it is useful to actually print the data and to see, okay, how is that graph rendered, right? So this is underneath the hood of what's driving that graph, okay? So there's a couple other things I'll take you through. We're looking at Jacquard similarity. So this is how we're getting how similar these relationships are between these people. Remember I said you can define the weight or the seriousness of that relationship to be more likely, like you're very likely to know this person. We'll recommend these people who you can add to who you may know list, or recommend a whole bunch of people that you might not know that you want to network with and share your profile with, share your information with, and get to know that person. So this is just a different kind of approach for that. Okay. Again, you have your scores or your weights over here, so you can increase that or decrease that. Really personal preference. Really, it depends on what you're trying to accomplish. And then we are going to print the scores of these relationships. So again, so we can prove that the relationship is either very strong, maybe intermediate, or maybe actually pretty weak. But to know the scores and to assign some type of ranking element or some type of ranking metric to these relationships, I think is good too. So I think this is a great view. I think that's a great visual to present to the people you're working with, to print out the details of that, okay, to get everything over here. I think that's a great idea too, but also to understand the scoring mechanisms and how to quantify how strong these relationships really are. I think that is important too. And you can see over here, same company, yes or no. This is a binary outcome, right? Same school, yes or no. If it's a 1, it's a yes. If it's a 0, it's a no. Same city, yes or no. So you can see the people that have more likely to have a relationship or to engage in a relationship, right? And do this networking on LinkedIn or whatever type of system you're using, right? And we assign a metric to that. That is what I'm calling score over here. And you can see AUC is area under the curve. So 65.4% of the time, these recommendations are going to be meaningful, they're going to be significant, and they're going to be accurate. But it's not going to be 100% accurate, right? Because people are people. Maybe somebody doesn't want to network with you. Maybe you reach out to them, they don't want to reach out. So it's never going to get to 100%. But if you get to 65% here, I think this is pretty decent. I think it's a pretty decent type of accuracy measurement. So just to wrap things up over here, I did have something in my notes, right? So with same company, same school, same city, these are binary flags. I think I covered that. And the score weights favor graph proximity. And you get a little more detail over here than you have just with the flag. The flag is binary, it's yes or no. The score actually assigns a quantitative metric so you can see how strong these relationships are, okay? So 668, I think it was 6.5, right? I ran that yesterday, got a slightly different outcome. That's okay. These things are kind of dynamically created, so it's going to change just slightly. So this is going to be 65%, but still decent accuracy. 0.5 is random, 1.0 is perfect. We'll never get to 1.0. That's ridiculous because again, you could want to network and reach out to somebody and they'll just ignore you, right? They'll just ghost you or whatever it's called. So you're never going to get 100% perfect accuracy. I think in this case, 0.65 is different. Now I've done a lot of ML algo work over the years. 0.65 is not good in some scenarios. You want a much higher type of precision, maybe high 0.9s, 9.5, 9.6, 9.8 to be fully confident, right? But in this type of scenario, I think 0.65 is very reasonable. Okay, so let me refresh this. Okay, and that should finish off 0.69. So a little bit higher accuracy over here. So I'll update that 0.69, 69%. But again, when this stuff runs, there's a random element to it. So you're not going to get exactly the same result each time, but it should be pretty similar. It should be within the ballpark, definitely. So again, this mirrors LinkedIn's concept of people you may know and how to create a list of these people at a high level. It's not exactly what they do, and I don't know what they do. I've never worked there, but I'm saying this is probably how they do it, or very substantially similar how they do that. And you look at different connections, the quality of those connections is important too. Any kind of users with connections that can potentially attract more connections, that is something that would be appealing. I'm not really doing that in this scenario, but that might be the next step here. Looking at profile similarity, like I said, same school, same city, industry, title, things like that. You probably want to connect with the person. Maybe, maybe not, but it's worth a look, right? And then we did some ranking right at the end. That's what this scoring metric is for ranking the potential relationship. And I'm using Jacquard similarity to measure how much relative homogeneity or heterogeneity, homo being the same or hetero being different, how much overlap is there relative to the total unique items. So this Jacquard similarity is pretty interesting. I've used that for different types of analysis. I have a couple videos on how that works, or at least one, maybe one or two, at least one. So you can keep an eye out for that if that's your thing. So I am going to wrap it up here. I think I covered everything that I wanted to cover. The video is just 24 minutes, not bad. I try to keep these under 30. If it gets over 30, I feel like sometimes they drag. Some of these actually went over an hour, but there was a lot of material to cover. But I think for this, you can summarize everything in 30 minutes and hit all the points nicely. So that's it. I'm going to wrap it up here. Thanks for your time and attention. I will save this file and I will share all the source code with you so you have everything you need to simply copy and paste this, run it in your own Jupyter notebook. And of course, make changes to those weights, make changes to some of the inputs that I showed you before, and just experiment with this and have fun with it, right? Take it apart, put it back together, see how everything works. That's the best way to learn. If you only watch the video and never run the code, you're not going to learn as much as if you copy and paste the code and run through it line by line and really examine it and really, get down into the weeds, you're going to learn a ton. Just watching the video while you're having dinner, probably not going to learn as much, but that's really up to you, right? So that's it. I'm going to wrap it up, and I will see you guys soon when I post the next video. Thanks. Goodbye for now.